Hello everybody, my name is Connor Thompson. This is my Physics 2012 Lab 1 report. This lab is all about analyzing electrical force on objects and how these forces influence objects with respect to other forces like gravity. To do this, we will charge two pieces of tape and use observed interactions to calculate things like charge, excess electrons on a piece of tape. There's a net force due to gravity and electrical repulsion. We analyze this data through predictive models like low script code. This lab primarily deals with concepts of net force, electric fields, charges, forces, Coulomb's law, gravity, and others. The observed tape that we are doing is the system. Surroundings could be the air tape used to cause it to float, the one that we're pushing underneath it, and maybe wind within the room. The main result was that each tape had a charge of roughly 2.83 e negative 7 coulombs. Furthermore, in the introduction, the equations that we really used were Coulomb's law, electric field, gravitational force, electric force. The charge from electron is given, tape density was given, and these equations and values were used to calculate things like the field of the tapes, electron efficiency of the tapes, force of gravity on the tapes, etc. One of the results sections that we had were the coded model. So that's the code there on the left. That's the predicted model on the right. You can notice there's a difference. There's a disparity in the size of the arrows, and I did that on purpose with a scale that I added that I'll get into later, just kind of to show how there's a difference in the magnitudes. Even if it's small, there's still a difference in the magnitudes of the electric field between the two tapes. That is a force graph that I showed for the top tape to show how the tape A repulsion force kind of pushes it up and force of gravity pulls it down. Those are equations on the right. That's just electric field uh, or electric charge of the tapes. That's the number of deficient electrons. That is the number of atoms per the sticky side of a tape, and that's just the ratio of deficient electrons to the number of atoms in the tape. Back in the experiment, tapes are initially neutrally charged. No electrons yet. We place a piece of tape with a Florida handle on desk and we rip two tapes off of it to produce positively charged tapes, and we know they're positively charged because they attracted to negatively charged plastic pens that were rubbed in human hair. And we had two charge tapes. We hovered them over each other, as seen in figure 4, to observe repulsive forces. And we observed the distance between the repelled tapes as roughly 0.75 inches, and we could determine the tape's charge from this. We also gathered the mass of tape using the tape's density as 0.2032 grams, allowing us to calculate things like charge and number of atoms on the sticky surface. The background of the code, we had variables and basic aspects that were first defined in the program, such as K, electron charge, electron efficiency, and all these came from the experiment. Charge is calculated by multiplying electron efficiency and electron charge together. This produced a value very similar to what we calculated by ourselves in our lab experiment, which is a very good thing. And then, as I said before, scale was defined earlier to make the graph look more obvious in its disparities of vector magnitudes, even if it's pretty small. R was determined as 0.019 meters. This is the gap from 0.75 inches that was observed when they repelled each other. R magnitude and R hat were calculated so that we could then find the electric field using Coulomb's law, and then we subtracted this with the gravitational force because that is still impacting the tapes, even if it's not that much of force. And then the arrows were drawn with respect to the scale adjustments to show this vector of magnitude. Experiment results, well, we had the distance measured, the mass of tape was measured, length of the tape was measured, force of gravity was calculated based on the mass in kilograms with the gravitational constant. Charge per tape was calculated with this equation down here on the top left of these images. You can see as 2.827 e negative 7 coulombs. Electron efficiency was calculated by dividing the charge of an electron. Number of atoms was calculated, and the ratio of deficient electrons to atoms was calculated here. And similarities and differences, the electron charge produced by the program using electron charge and the number of deficient electrons is slightly off from what we observed, likely due to either errors in the tape mass variable or just calculation errors. What does it mean? Why is it important to handle the charged tapes as little as possible? Well, if you believe that the adhesive part of the tape gives it the ability to kind of strip electrons away and give it its charge, handling this tape removes its adhesiveness, which could cause it to lose its charge over time. But if you believe in like the idea of how we can ground things to the earth, if you're touching the tape and it has a charge, it'll still lose that charge because it's transferring to your hand. What if electrons has positive charge and protons had a negative charge? Well, the labels would be flipped because electrons would now be positive, but the physics was still the same because like charges repel and opposite charges attract. The tapes would still repel each other because they are both charged with the same charge, but instead of the tapes having electron efficiency, it would be a proton efficiency to give them this charged property. As stated previously, some sources of errors between what was observed and what was calculated by a glow script code likely stem from the input variables, but there could have also been errors in calculating the number of deficient electrons that we did and the number of atoms, as these two values divided produced a ratio of deficient electrons to the number of atoms that seemed very high. It was about 870 electrons per atom. But the errors in calculating this probably stemmed more from the number of deficient electrons because the number, or this stemmed from the number of atoms because the number of deficient electrons, as we said before, was confirmed through the glow script code. Even if it was negative and a little bit off, it still was roughly the same magnitude, so the number of atoms was more likely to cause that error. But overall, this experiment was very interesting in showing how normal objects such as tape can become charged through the steering of electrons between adhered objects. It also shows how more complicated values, such as electric field values, can be calculated based on the properties of the tape and the observed separation distance between the repelling tapes. Thank you for watching.